Scientists like to classify things because it helps us make sense of all this information that we find out. And so we need to think about the different classifications of matter. We can divide matter into two broad classes, mixtures and pure substances. Mixtures are composed of more than one substance, two or more things mixed together, right? They can be physically separated into their components. So you mix two things together, you could take them apart again. A pure substance, on the other hand, is composed of only one substance, and you can't separate it through a physical means. You can't filter it or use a magnet to separate the two components. There are two kinds of mixtures. So we've got pure substances and mixtures. We'll talk about the mixtures first. Two kinds of mixtures, homogeneous and heterogeneous. We use a lot of prefixes and suffixes in chemistry. And so homo is a prefix that means the same, and hetero is a prefix that means different. So a homogeneous mixture is one that has uniform properties. It's the same throughout. Something at the top, something at the bottom, in the middle, it's all the same. An example of this is salt water. If you put salt in water and stir it up, the salt will dissolve, and it will form a homogeneous mixture. There's the same amount of salt at the top and the bottom. If you tasted different sections, it would taste equally salty, right? An alloy is a special kind of a homogeneous mixture. It's a mixture of metals. So things like stainless steel, sterling silver, brass, pewter, all of these are homogeneous mixtures of metals. The thing about mixtures, is that you can have a varying proportion of the different components. Like salt water, you could have a little bit of salt in the water, or you could have a lot of salt in the water. Mixtures, you can vary the proportions. And so there's different grades of steel, and they're identified by how much carbon they have, and how much iron they have, and how much of the other metals they have. So here's a joke for you. If the Silver Surfer and Iron Man work together, would they be alloys? Yeah. That's one of those groaners. Okay, heterogeneous mixture. Hetero means different. So these do not have uniform properties. If you think about sand and water, we put water and salt and we stirred it up and it all mixed up real nice. What if we take a teaspoon of sand and put it in a glass of water and stir it up? Can we get that sand to mix up and stay mixed up? No. As soon as you stop stirring, all the sand's going to fall to the bottom. There's sand on the bottom, there's water on the top. They're together in the same container, they're mixed up a little bit, but they're not uniform, are they? Think about macaroni and cheese. There's the cheese sauce, and then there's the macaroni, right? And you can tell it's lumpy. There's different parts. Think about something like chicken noodle soup. There's chicken and noodles and the broth. But you think about something like beef bouillon, it's the same throughout. There aren't any chunks or cream of tomato soup. It's all been pureed together and it's homogeneous. So heterogeneous versus homogeneous. Those are the types of mixtures. Then we go back to the pure substances, the other type of matter, and we can divide these into two groups, elements and compounds. Elements are things that cannot be broken down further by a chemical reaction. Compounds can be separated chemically into individual elements. Now, they cannot be separated physically. Water is a compound. It contains hydrogen and oxygen, but it's not a mixture. You can have a mixture of hydrogen and oxygen. You can put them in a balloon or something. It's very flammable. When you light a match to it, it goes kaboom. I've seen it done in a lecture hall like this, and all the ceiling tiles went whoop. And then people come running. What happened? Oh, just a demo, a little too big on the balloon. Right? Very explosive. It's a mixture of hydrogen and oxygen. You could separate them. It wouldn't be easy, but you could do it. You could separate the hydrogen and the oxygen. Water is a compound. The hydrogen and the oxygen are chemically bonded to each other. And the only way to get them separated is by a chemical process. Forgetting what pictures. If you're interested in separating water into hydrogen and oxygen, you can do that at home very easily by taking a 9-volt battery and dropping it in a glass of water. And you'll see bubbles forming. At one terminal, it'll be oxygen. At the other terminal, it'll be hydrogen. And you can destroy water that way. It takes a lot of energy to do it, though, so it won't really have any effect on the drought. Here's another picture. Here we have chlorine gas. No. Well, yes. Chlorine gas up there and sodium metal down here. So these are elements. Sodium, all the particles in here are just sodium atoms. In here, these are just chlorine. And we mix these two together, they form a compound, a chemical compound, a pure substance from the elements. So it's two elements that are bonding together. There's a chemical transformation. It's rather vigorous. That's flame in there. And the result is table salt. Compounds and elements can have extremely different properties. Sodium is a metal, and it explodes when it comes into contact with water because it reacts so violently. Chlorine is a poisonous gas. So both of these would be bad to eat, right? Sodium chloride, on the other hand, is an edible food additive. And yes, too much of it's bad for you, but you need some of it to stay alive. So the properties of these are very different. So this is sort of a summary of this division of matter. Here we have matter. There are mixtures, and there are pure substances. You can take a mixture and separate it physically. So think about the sand and the water. How could you separate them? What if you poured it through like a coffee filter? The water would go through the filter paper, and the sand would stay behind. That's a physical separation. You can't do that with a compound, but you can do it with mixtures. So of mixtures, we have heterogeneous. This is oil and water. You can shake up that vinegar and oil dressing all you want, but as soon as you put it down, it's going to separate back out, isn't it? And there'll be an oily layer and a vinegary layer. And you can have homogeneous solutions. Here the picture is of a 0.9% sodium chloride solution that they might use in an IV. And so it's water and it's sodium chloride, and it's mixed uniformly throughout, but it's a mixture. Then we have the pure substances. We have compounds and elements. Compounds can be separated chemically into elements. And when we look at the particles of a compound, we see that there's more than one kind of element in there. And if we look at an element, all the particles are the same. Any questions? Examples. Classify the following as an element, a compound, a homogeneous mixture, or a heterogeneous mixture. Wine. Homogeneous mixture. So we'll call that HM. Homogeneous, well, actually we can't. Homo mix, maybe. I don't know. Gold. That's an element. So gold is an element. Might seem like cheating, but if you see this name on the periodic table, it's an element. All the elements are listed on the periodic table. And we'll get better at identifying these things. Carbon dioxide. This is a compound. It's got carbon and oxygen, and they're in a specific ratio. So this is a compound. How about orange juice with pulp? That's heterogeneous. A heterogeneous mixture. Okay, so you should be able to answer questions like that.